Okay, so I'm gonna explain to you guys about my most impressive line of code. I wouldn't say line of code, it's more like two code files that I'm gonna be comparing to. Okay, so the first one that I'll be comparing to you guys is a code with no LLM method, and the other one is we use LLM. So for the non-LLM one, uh, okay, so for context, for my application to function correctly, we need to estimate the height and for the child and also the baby. And with the non-LLM one, we use mathematics. So of course we use NumPy. We also use OpenCV to detect all of the features that the picture have. So yeah, as you can see here, we have landmarks of like maybe the head, the nose, etc. And with those landmarks, we calculate like let's say like the head to shoulder height, or like the shoulder to hip one, etc. And with that, we estimate the height. Okay, but the thing with the non-LLM one is that we have these scaling factors that yeah, we can adjust all the time, but it will always be constant. It will always be 0.00012. So we can't really it's not that dynamic, let's say. So yeah, after we add all of these, we times it with the scaling factor, which it won't be that accurate if it's just like, let's say, if we compare a baby of like an Asian one or like the African one. Obviously they have like different head to shoulder ratio, let's say. And yeah, after that we return the estimate height. And yeah, so that's pretty much the non LLM code. But as you can see here, I have the LLM code, which is we use AI to help us figuring out the output for the height of the child. So yeah, this is all pretty much the same. We got their landmarks, and then we know their proportions, their head to shoulder. Now, and then like over here, this is where it is different than the non-LLM code. We prompt this, so like we ask an AI to estimate like the height of the children instead of us calculating it by ourselves. So yeah, we ask the AI for like their height, and we input like all of this like head to shoulder, shoulder to hip, etc. Okay, so let me demonstrate it. Right. So this is what we'll be using for the AI server. It's Google Vertex. Okay, so right now I'm gonna change it to maybe like 50, 50 to 50. Then last but not least, 300. Then this, we could just say like 1, 2, 3, then 4. And it should be, yeah, it output us the estimate height of the children slash the baby. But this is where it gets interesting. If I say like this person is Asian, it's gonna give us a different output because it has like their own scaling factor, so it is more dynamic. Okay, so that's pretty much it about what's interesting about me is that the fact that we use AI to predict the output instead of using a more rigid and non-flexible calculating style.